Hello, this presentation is part 3 of my 3-part series on key concepts that I believe will impact your low-power design efforts the most. In this section, the third and final section, I will discuss the creation and use of power budgets. While this is neither a hardware or software item, this is about planning effectively for many beneficial reasons. Okay, let's get started with our discussion about power budgeting. Writing down a power budget is important for a number of reasons. To study feasibility, to set goals and compare design methods, processes, and components. To explore options, create what-if scenarios, and it's also great IP for your next design. System design is an iterative process with many steps. Your power budget is a valuable tool throughout this process. This is a list of 3 areas that make up my power budget: power source definition, device loads, and use case calculations. I do my power budget on a spreadsheet, which is the main reason why this section is brief. That is, because I know how tedious it is to sit through somebody else's long spreadsheet derivation. I also have the entire spreadsheet available for download on my Git repository, so you can examine it based on your individual needs. I have the address where you can download the spreadsheet at the end of this presentation. So let's continue with a quick orientation. Shown here is what my workbook structure looks like. The sheets highlighted in red contain the power source capacities and device current consumptions and rate data. The sheet highlighted green is a brief summary sheet. The sheets highlighted in blue are my use case worksheets. This is the first worksheet. You will notice that I use color quite a bit. For instance, bright yellow helps me locate and remember key parameters. Each device subsection begins in dark green. In the column on the left, I list the names and the modes and features that I plan to use in my use cases. The main, or down-selected features, and their associated values are highlighted in yellow. These are the values that I will be transferring to my use cases. Related to these selected items in yellow are the light green colored items. These serve to highlight the key attributes which denote why they were selected. For example, the AP Run Fast. It was chosen because it has the highest instruction execution rate of 32 MIPS, which I plan to use in some situations. And the value that I will be using in my use case worksheet is the current consumption value of 12,300 microamps or 12.3 milliamps. And lastly, red is reserved for showstopper items. These items have features or values that do not meet the needs of my application. Next is the device consumptions and rates worksheet. This slide shows just a portion of the device power consumption worksheet. Many more devices and functions exist in rows below the ones shown here. As you can see, I've created names for the various device functions and events in such the same format as shown in the first section. The data I plugged into this sheet are values that I've gathered from datasheets. Sometimes additional calculations are needed, which I also perform on this sheet as needed. I even add the I2C bus transaction burden. Since the frequency is fixed and the number of bytes is variable and dependent on usage, the current consumption is calculated in units of charge per unit byte, or microcoulombs per byte in this case. One way to look at this is that for every byte transferred, a finite number of electrons are going to be depleted from the power source, a battery in this case. We'll see more of this type of calculation and its usage in the use case worksheets in a moment. The bottom of the same worksheet is shown here. I established the rate for the Bluetooth data transfer, and like the I2C traffic, the system burden here is also related in charge per unit byte transferred. Notice this worksheet also includes a tally of the entire system quiescent currents and given in the mode named System IQ. Next up, the summary page. To put things in perspective, I put what I call full-time usage calculations on the right side. This is kind of a Pareto chart, if you will. It basically shows how long a battery would last for each individual function or event, or how many bytes could be transferred under the lifetime of one battery. These calculations are a great way to gain perspective on the strengths and weaknesses of your system. All the key data from the previous input worksheets are summarized on this worksheet. I call this my scrimmage sheet, as it contains all the values that I plan to use in the use case worksheets. Okay, this is where the rubber hits the road, use cases. I relate all my calculations in units of charge. That is the end result in the far right column, which is automatically conditionally colored based on its event's total charge usage relative to the other events in the worksheet. The cells highlighted in green have the lowest charge consumption, and the cells highlighted in red have the highest. Charge is the common unit of measure and is directly related to the power source capacity. Actions on this worksheet include data transfers, constants, quiescence and sleep currents, instruction executions, and user events. Here is a data transfer example. This shows that it takes 5,634 microcoulombs to transfer 32,000 bytes of data over the Bluetooth BLE device. The bottom line is that it's going to take 5,634 microcoulombs of charge away from my battery every time I want to transfer 32,000 bytes of data. This is an example of something that's on all the time. This is the constant current example. In this case, the accelerometer is on the entire duration of this use case, which lasts 168 hours. So for the entire duration of this use case, it will consume roughly 6.6 coulombs of charge from my battery, which is almost 10%. This is an example of executing instructions by the microprocessor. In this case, during the entire 168 hours of this use case duration, I'm going to wake up every 5 minutes and execute 100,000 instructions. So for the entire use case duration, this is going to consume 14,000 microcoulombs, which is a very small percentage of my battery. Now here's an event example. In this case, the user is going to check status of the device 10 times during the use case duration of 168 hours. It had already been calculated that each event is going to require 9.2 nanocoulombs of charge. In this case, it's going to be checked 10 times, so 10 times 9.2 nanocoulombs is 92 coulombs. Here's another event example. In this case, the user checks the battery level 10 times, and it requires 60 nanocoulombs for each occurrence, for a total of 609 nanocoulombs over the duration of this use case. And that's all I have to show you. Like I said, I didn't go too in depth. It's really meant to introduce you to the method that I use. And to explore it deeper, you can download the spreadsheet from my Git repository shown below. Thank you for listening.